Hello everyone. In today's video, I'm going to share with you two questions from GCE O-level papers on prime factorization involving highest common factor HCF and lowest common multiple LCM. The first question is taken from GCE O-level, the year 2013, paper 1, question 7. The question goes like this. A. Express 294 as a product of its prime factors. B. A number has exactly 8 factors. 2 of the factors are 8 and 20. List all the factors of the number. Let's begin. Paper 1, question 7 of 2013. Question A. Expressing 294 as a product of its prime factors. So, doing this, we need to use prime numbers 2, 3, 5, 7, 11, and so on. And we have to use repeated division. Okay, all right. So I'm going to do now this way, and we have 294. Okay, and then we all know that 2 is the smallest prime number, so we have to use 2 first because 294 is an even number, so 294 can be divided by 2. It gives us 147. Now 147 is an odd number, so 2 is not the prime number that we should use as a divisor. So we are going to move on to the next higher prime number, which is a 3. Now 147 can be divided by 3. It gives us 49. Now 49 can only be divided by the next prime number, which is 7. So 49 divided by 7 gives us a 7. And we can't end here because our repeated division must end with a 1. So this is a 7. Okay? Alright, so part A is done. 294 written as the product of its prime factors. It should be 2 times 3 times 7 times 7. Simplified, express it into this way. 2 times 3 times 7 to the power of 2, or 2 times 3 times 7 square. Okay, all right. Part A is done. Okay, I'm going to move on to part B in my next slide. Part B. A number has exactly 8 factors. 2 of such factors are 8 and 20. Let us list all the factors of the number. So, we all know that a particular number, right? I'm going to use what we learned in P4. So, is 1 times something. Okay? Like that. There should be 8 factors. That means there should be altogether 4 pairs. There should be altogether 4 pairs. Okay? Now 1 times something, something times what, and so on. Then that means there must be 4 pairs to give us 8 factors. And there are no repeats. Okay? So now we all know that 8 and 20 belongs to one particular one of the factors. So I presume, okay, that 8 is one of this. Okay, and 20 is one of this. So 20 is very high. It's very large number. Now, if this is 20, I'm going to use a little bit color. If this is 20, then we have 2 and 10, 4 and 5. That gives us only 6 factors. So 20 is definitely not the number. 20 is not the number. Okay, so I'm going to remove all this. So it's not 20. Now it must be a multiple. That means it must be a common multiple of 8 and 20. Alright, so what is common in 8 and 20? What is common in them? So, alright, so it can't be 20 because 8 is not a factor of 20. So the maximum number is not 20. So, and it must be a multiple of 20. That means we can look at 40. Alright, let's try 40. So if this is 40, okay, alright, so 1 times 40 is the first pair, 2 times 20 is the second pair, 3 cannot be done, 3 is not a divisor of 40, 4 and 10, okay, then we have 5 and 8, right, and then that's about all. Yes, so to list all the factors of number, so 40, all the factors are 1, 2, 4, 5, 8, 10, 20, and 40. Right? So the answer will be a list of 8 numbers, and the 8 numbers are, the 8 factors are 1, 2, 4, 5, 8, 10, 20, and 40. And part B is done. Not difficult, right? Okay, now we have completed question 7 of paper 1, 2013. I'm going to move on to the next question. Today's video. It is taken from GCE O Level 2015, paper 1, question 14. The question goes like this. A. Express 450 as the product of its prime factors. Easy, right? This one we have been doing quite a lot. And part B, find two numbers, both smaller than 100, that have a lowest common multiple of 450 and a highest common factor of 15. Part B sounds a bit abstract, but can be done, because we have learned LCM, HCF in my previous videos. Okay, let's do part A. Express 450 as a product of its prime factors. This one should not be an issue. We just need to do repeated division. So 450 is an even number. So let's use the smallest prime number 2. This will give us 225. Now we end with a 5. Automatic, we know we have to move on to a 5. Okay, we can use 5. No issue. Okay, so 225 divided by 5, okay, will give us 45. Now, you can try a 5 again because the ones place are 5, right? Digit 5, so we can try a 5. We'll get a 9. Now, 9 cannot be divided by 5, but we know that there's a prime number 3. So we can go back to 3 again. So it's okay. It doesn't have to be in order as long as we are exhausting as many prime numbers as possible to get the final quotient 1. Okay, so 9 divided by 3 is a 3, and that finally gives us a 1. The 1 at the last part of the repeated division says that prime factorization is completed. Okay, so what is the 450, the product of factors? What are they? So 450, we have to write down now in increasing order. We start from the small number. So 2 appear 1 time, 3 appear twice, and 5 appear twice. Rewriting this, 450 is equal to 2 times 3 squared times 5 squared, written in its index notation. Okay, all right, so A is completed. Not difficult, right? Okay, I'm going to move on to part B in my next slide. Part B. Find two numbers, both smaller than 100. So it must be smaller than 100 and must fulfill two conditions. Have a LCM of 450. Let me write down. Must be LCM 450 and HCF 15. So we have to check this two. Okay, and it must be smaller than 100. Okay, let's go. All right. Okay, now to do this question, okay, we can use this as a clue. The first one, LCM 450. So let's do the prime factorization of 450. No need because we have done it just now in part A. So let's retrieve part A's answer. It is 450 is equal to 2 times 3 square times 5 square. Okay, I'm going to break this so it's easier to do afterwards. Okay, like that. Okay, all right. This is taken from the answer from part A. Okay, now we want to get two numbers smaller than 100 and must fulfill these two conditions. Okay, all right. Okay, now what we do is we make use of the factors 2, 3, and 5 to get that smaller number. Okay, all right. So what happened is it must consist of the highest common factor 15. That means it must have this 3 and 5. So I'm going to block up these two values first. It must have these two. Okay, that means our two numbers must consist of the digit 3 and the digit 5. That gives us 15. It must have these two, the product of these two factors. Okay, now let's think of our first number. Okay, let's think of first number. Okay, if the first number, let's see, right, we shall take from the list here. If we take the entire 2, 3, 3, 5, 5, we have 450. No, we don't want that. Okay, so let's take the first 4. Okay, so 2 times 3 times 3 times 5, okay, gives us 90. Okay, 90. All right, so 90 could be one of the numbers, and anyway, and it also is smaller than 100. So the 90 looks good. 90 looks good. Okay, so that's one number. Okay, let's try to take the next lot. Perhaps we take double 5. Okay, so let's take double 5. So remember, we must always have this. I'm gonna box it up again. We must always have this. Okay, okay. So let's do the next guess. Let's have 3, 3, and 5, and 5. Okay, we have this, right? We have this. Okay, that one means it's a highest HCF. Now, if HCF is 15, okay, all right, then will this give us the answer? 3 times 3 times 5 times 5. Now, 3 times 3 times 5 times 5, what does it give you? 225. Okay, 225. Now, this 225 is more than 100. So this guess is out. This guess is out. Cannot. All right, we are not allowed to have that number. So we cannot have double 5. We cannot have double 5 already. Okay? All right? Okay, so since we can't have double 5, then we'll have double 3 and we have double 2. Okay, let's have double 2. Okay, so 2. No, we cannot have double 2. There's only 1, 2 here. Okay, so 1, 2, 2. How about this? This combination. And we still fulfill this condition. This HCF. Okay, so 2 times 3 times 5. So we dropped 1, 5. We dropped 1, 3. And we end up with only 3 factors, a product of 3 factors, 2 times 3 times 5. Okay, so 2 times 3 times 5 gives us what? 30. Okay, now 2 times 3 times 5 gives us 30. Okay, now why this 30 cannot be the answer? Is it possible to be an answer because it's smaller than 100? Okay, it is indeed smaller than 100, and 30 can give us a multiple of 450. But if you look at 30 and 90, if you look at 30 and 90, the one that is in red and green, the LCM is 90. So cannot, because we want the LCM to be 450. So cannot. 30 and 90 give us LCM 90. Okay, so we can't choose 30. So in the end, we have to move on to do a final guess. So the final guess, the last combination would be this. Okay, we drop the 2, so we have a 3. Okay, we cannot have double 3, yeah? So we take a 3 with double 5. 3 with double 5 give us 75. Okay, and then this is still fulfilling the condition. This one. All right, so 3 times 5 times 5 is 75, and 75 and 90, they really give us the LCM 450. So the answer is this and this. So part B, what are the two numbers? The two numbers are 90 and 75. Only 90 and 75 can give us LCM of 450 and HCF of 15. So this question part B is a little bit difficult to understand. So we have to do a little bit of guess and check. Okay, so remember, feel free to replay my video to have a better understanding of what part B is all about. All right. Okay, in today's video, I shared with you an extension of HCF and LCM using prime factorization, and I quoted 2 GCE questions. All right, I hope you find that knowing these particular 2 concepts is very important. Okay, right? Definitely it will be tested in paper 1 in GCE papers. Okay, coming up next will be square roots and cube roots using prime factorization. If you like my today's sharing, give this video a thumbs up, a like. Do give me your comments, your feedback, your suggestions, your motivation. Remember to share with anyone who likes to know more about prime factorization to find HCF and LCM. And most importantly, I strongly encourage you to subscribe. So when you subscribe, you'll get to be notified of all my videos being posted in YouTube. Thank you for supporting my channel. Thank you for viewing my video, for sharing my video, for uploading, or rather for downloading my video. Thank you for your motivation and encouragement. Till then, this is Joseph. Goodbye.